We have two different substances. We'd like to know here which of these substances supplies the greatest percentage of nitrogen by mass. Now, I'm not going to give the right or wrong answer here on this one. I'd like for you to gather an impression simply based on looking at the formulas. And my morning class told me we did not yet tell you that this has a common name that you are going to be responsible for. This is ammonia. Ammonia. So if we've not discussed it before, we are now. And so just like we call H2O water, we don't call it dihydrogen monoxide. We don't call this one nitrogen trihydride. We call this one here ammonia. It goes by its common name. And of course you should know the second one. This one you should be able to name. This one is ammonium nitrate. Good, ammonium nitrate. So, look over these formulas. And again, this one I'm just trying to gather your impressions. Which of these two do you think supplies the greatest percentage of nitrogen by mass? Is it ammonia? Is it ammonium nitrate? Or do you really have no idea? Answer honestly. What do you think? We'll get your answers locked in. We'll give you 5 seconds. 5, 4, 3, 2, 1. Okay, well, it looks like we're about 50-50 on this. That was very much like the morning class. So on this one here now, what we'd like to do is we'd like to see if we can figure out which one supplies the greatest percentage of nitrogen by mass. And here's how we go about doing it. First of all, we're going to calculate a percentage. And calculating a percentage in chemistry is just like you'd calculate it if you were trying to find a discount on a pair of shoes or a discount on a car. If you want to calculate a percentage, percentages are always found by taking the part and then what? Dividing it by the whole amount and taking that result and multiplying by 100. So again, percentages are always the part over the whole times 100. So to do this one, we're going to start with ammonia. And working with ammonia, how many nitrogen atoms are shown in this formula?
1.
And how many hydrogens?
3.
Okay, so we're going to calculate the molar mass kind of the long way here. We're going to write everything out. So we have 1 nitrogen with a mass of 14.01. We have 3 hydrogens, each with a mass of
1.008.
1.008. If we multiply these through, we get 14.01, 3.024. We sum these down, we get 17.03. Now if we're dealing with mole size quantities, these units would be, what would the units be if these are in moles? Grams, right. And actually it turns out that the units on here do not really matter, other than they are mass units, because any mass units will cancel out. If we want to find the percentage of this nitrogen, we take the part of this nitrogen, which is 14.01 grams. We divide it by the whole amount, which is 17.03 grams. Grams over grams, of course, cancel out. We take that result, multiply by 100. Okay. How many significant figures do we want? 4. So we're going to take 82.27 is what my calculator is showing here. Okay, 82.27% nitrogen for the ammonia. Now, you go ahead and calculate the percentage of nitrogen for the ammonium nitrate. Calculate the percentage of nitrogen for the ammonium nitrate. And once you get that, That is your next question on the Socrative app. What is the percentage of nitrogen, the percent by mass of nitrogen in ammonium nitrate? 3, 2, 1. Correct answer is 35.00%. Now, if you've done this correctly, here's how you'd go about setting that up. Ammonium nitrate, there's 2 nitrogen atoms shown in the formula. We have 4 hydrogens. We've got 3 oxygens. We sum them together, we get a total mass of 80.05. We then calculate the percentage by taking the part, dividing it by the whole, multiplying by 100. When we do so, we wind up with 35.00%. So we go back to the question we had just asked before. Which substance supplies the greatest percentage of nitrogen by mass? And that would be ammonia. The ammonia here at 82.27%. So any questions on the calculations? Okay, now, I think I may have told you before that I was raised out in the country, and so I did a little bit of help with farming and such. And when we did some work and we wanted to put on some fertilizer, of course the element of interest that's in here is the element nitrogen. And if we apply nitrogen, anybody know what nitrogen does if we apply a nitrogen fertilizer? What does that do to a plant? Well, you actually like it on your lawn. Yeah.
Doesn't it help speed up growing?
That does help it speed up growing, but more importantly, what do you want your lawn to look like? Green. Right, this is the stuff that makes it green. You want a nice green lawn? Well, you need some water, but you want to make sure that you have some nitrogen fertilizer. It's the stuff that gets your chlorophyll active and gets it to grow faster. So yes, the nitrogen is good for the growing. Now, kind of an interesting side note on here as well. If we look at these 2 particular fertilizers, each one of them has a particular application. Now, how many know what ammonia is? How many could identify ammonia? And how do you identify it?
Typically the smell.
Through the smell, exactly. So if you smell ammonia, ammonia is found in many types of window cleaners and other types of household cleaners, and so it has a very characteristic smell. When farmers apply ammonia, they apply it as 100% ammonia. If you smell it like in a window cleaner, you're smelling about 1%. So you basically take whatever you're smelling there and multiply it by a factor of at least 100, and that's what goes on when farmers apply it in the field. And if you drive out in the country and you see these big long, they look like long tubes, like a long hot dog on wheels. Those things in our containers are what are called anhydrous, is what farmers call it, which is short for anhydrous ammonia. And if you think of the word hydrous, what does that sound like? Water. And so the word anhydrous actually means without water. So anhydrous ammonia then is ammonia that's applied without water. And one of the things that's really good about it and bad about it, it's the same thing. The good thing about it is that it's super soluble in water. And the bad thing about it is super soluble in water. And so what happens when you put it into the soil, basically ammonia, and we'll demonstrate this later on this semester, but what we'll find out is that ammonia just seeks out the water and it latches on really tight, and that's what keeps it in the soil. Usually farmers, when they put it on, will put it on in the fall, and then it'll stay there in the spring once you're ready to plant. But the downside, again, is that it's also very soluble in water. And why is that the downside? Well, what are you and I mostly made out of? Water. So when this stuff is applied, if you're not careful with it, what do you think is going to happen?
Latch onto you.
Latch onto you, exactly. And so if you hear about like these trains or whatever that have derailed, if they've been carrying some ammonia, they'll evacuate whole towns and everything simply because of the fact that this ammonia winds up latching onto you. And farmers, when they apply it, they have to have special certification and training to use it, because if there's some sort of accident, the first place it's going to go is in your face and mouth, your eyes and everything, because that's where you have the water exposed, and you can lose your sight really quickly and get overcome by the fumes simply from inhaling, because your lungs are lined with the water as well. Ammonium nitrate has its own cautions. This one here is extremely explosive, and this was used in an Oklahoma City bombing. I don't know, most of you here are too young for that, but if you've learned any of the history, it was an event that took place in 1994, and it was a case of domestic terrorism, and there was a guy who filled up a rental truck with about 1,200 pounds of this stuff.
Timothy McVeigh.
Timothy McVeigh, yes.
He was put to death for it.
Exactly. And doused it with diesel fuel, put about a 10 to 12 foot crater in there, and about 180 people died as a result of that event. But when you and I think about fertilizer, this is what we usually think of, because this is the stuff that comes in the solid phase. If you go into a garden supply center, this is the type of stuff. Now, we can't actually buy this. This is still pretty much farmers restricted to this, but this gets to be the type of stuff where if you spread it out, it winds up being a solid. And this stuff would be applied if we know like there's rain coming, because this would then wind up taking it down into the soil once the rain comes. So, good on the history there. Now, there's some other values. For example, if you go and purchase fertilizer, you're going to see some numbers that are published on the bag of fertilizer itself. You might see something like 10, 10, 10, or you might see something like 2708. Know what these numbers stand for?
The ratio between the nitrogen, and the oxygen found in the fertilizer.
Pretty close. You were right on the first one.
Ratio?
Well, it's the ratios, and you were right about the first element. Nitrogen's the first one.
Okay.
Second one is
Phosphorus?
phosphorus. The last one is potassium. They're called Npk values. Npk values. And respectively, they stand for the percentages of nitrogen, phosphorus, and potassium found in that particular fertilizer. So if we had something like ammonium nitrate, this one right here, ammonium nitrate, the numbers that would be found on such a bag would be 35 dash. How much phosphorus is in here? 0. And how much potassium is in here? 0. So the numbers for this would be 3500. So if you had one that looked like this, 10, 10, 10, this means it would contain 10% nitrogen, 10% phosphorus, and 10% potassium. And as far as what each one does, we already talked about nitrogen. Nitrogen is the stuff that makes your stuff green, or makes it grow. Okay. Then P, this one here, is the stuff that gives you fruits and flowers. So, and this is true whether you're growing peas or green beans or apples. If you want something to produce large fruits, and by fruits we don't mean just like apples and pears or whatever. Anything that comes from a flower is what we're talking about. That's what P helps you with. And K, this would be the stuff that gives us healthy roots. Now there's an easy way to remember this one, because what's one root crop that probably most of us eat in here? Potatoes. And potatoes are very high in potassium. So that's an easy way to remember. Potatoes and potassium. So the K value helps us with the roots. The phosphorus. This one here, by law in Minnesota, if you put it on a lawn, that value must be equal to 0. Anybody know why we don't want any phosphorus in our lawn fertilizers? What's that?
Something to do with our wetlands, because we have such big basin areas, and then it often pollutes our water bodies.
Yes.
Produces like frogs with extra legs.
Not so much the frogs and extra legs, but the bodies of water is definitely a very important thing. What do we have a lot of in Minnesota? Lakes, exactly. We have a lot of lakes. And so if you're swimming in the summer, what kind of lake do you not want to jump into? A green one, right. And you jump into a green one. If it's green, it's because that water is very high in phosphorus. And it causes algae blooms. Okay, so then when we talk about things blooming and fruiting, it causes algae blooms. And so the way it gets out there is if you put this stuff on your lawns, you get a heavy rain, where does the water go?
To the nearest lake.
Yeah, well, it gets to the nearest lake, first of all, if you live in town, by going out into the storm sewers that are out in the road, and those storm sewers actually wind up going right out there, out into the Mississippi River. They wind up going to lakes and creeks or wherever else. So by law in Minnesota, if you put a fertilizer in your lawn, this value here has to have a 0 value.
How do you, how do they reverse that then? Like, let's say the lake does have a bunch of algae.
Well, through time, plants will consume it, but you were talking about things that like to grow with it. I mean, like in wetlands, whatever, then you might up having a lot of plants that'll grow weeds and whatever else and will flower. Eventually it will get consumed, but the lakes then kind of, they get smaller as more vegetation and stuff grows around them, and they can't, the wetlands, whatever, the banks start encroaching in on the lake itself. Eventually, though, it will wind up disappearing through precipitation. And by precipitates, just like we talk about chemistry, by things precipitating. If you get calcium in there, calcium phosphate is very insoluble. So anything that has calcium will then cause it to precipitate and basically winds up sitting at the bottom. Kind of another interesting thing here about phosphorus is this is kind of probably of all of them the most important for our food supply is phosphorus, because you know, if we're not eating any vegetables or whatever, then we're eating meat, and those things, in order to get meat, those animals have to eat things like corn and soybeans and whatever else. And that's going to come from phosphorus. And so we can't keep taking phosphorus up out of the ground. So that phosphorus has to come from somewhere. And that somewhere it comes from is places that have built up what's called phosphate rock over hundreds of thousands and millions of years. And it's kind of the same place where we wind up finding oil. And so we've all heard about, well, at some point in time we're going to use up all the oil in the world here if we keep pulling it up out of the ground and all the coal. But one thing we haven't heard about is that we're also going to wind up running out of phosphorus, because we wind up mining this and taking this out of the ground as well. And this is stuff that's been come through millions and millions of years of vegetation dying and plants and animals dying and building up. But if we keep taking this out of there, then there's nothing to replace it. So at some point, our descendants are going to have to grapple with this issue. We've heard again about oil prices. I mean, we can't tell by the price of gas today, but at some point, we're going to have to deal with that issue again, and we're going to have to deal with issues of phosphorus as well. And what's going to happen, in all likelihood, and here's another way to remember this, a good source of P is actually P. Okay? Urine is high in phosphorus. And so what's probably going to happen 50, 100 years down the road is that when you go into the restroom, we probably aren't going to be flushing toilets, because that winds up back out there in the river. What's probably going to happen is there's going to be methods that are going to be used to retrieve all of our waste, especially the urine, because it's going to be a very high source of phosphorus. And that phosphorus is going to be used as a source of fertilizer for our plants. So it's kind of a cycle here through which everything winds up going through. So if we get back to the stuff that we're looking at here, sometimes doing our homework, we might come across a problem like this. And I might read, what is the percent by mass composition of a substance? And since we started with ammonium nitrate, let's continue with ammonium nitrate. Now you notice in this one, we've not specified an element. So if we don't specify an element, and we want to know the percent by mass composition, we then calculate the percentages for all of them. So in ammonium nitrate, if we wanted to find the percent that is oxygen, we would come back here. We see that there's 48 grams of oxygen for every 80.05 grams of the ammonium nitrate. So we take the 48.00 grams, divide that by the 80.05 grams, multiply that by 100, and we come up with 59.96% oxygen. So now we have these two percentages. The only element that we have left to go now is hydrogen. And we could calculate hydrogen in the same manner. Or what is another way we could calculate the percentage of hydrogen?
100%.
Take 100 and then minus the 2%.
Right. We could take 100, subtract from it the 59.96 and the 35.00. And if you do it this way, looks like we wind up with 5.04% hydrogen. And of course we can do it this way because the percentages must sum up to be 100%. So any questions on this one here? And somebody asked about this morning. Somebody said that some bags will actually have a fourth number on there. If they do, that fourth number is S, which of course stands for sulfur. And so if there's a fourth one on there, usually that number is going to be pretty small, but the sulfur is used for protein synthesis. So anything that has protein, enzymes, whatever in it, would need sulfur in it as well.